Alrighty, so number 2, we left off on finding the mean. That was easy peasy. And then I got stuck with the standard deviation, right? So I'm going to go ahead and erase this so I can show you what is happening. Oh, I can't erase it. Hold on. Hold, please. All right. Let's see. Can I delete? Man. I deleted the whole thing. My bad. Okay, hold on. Let me see if I could do this. So I'm just going to go ahead and write over it. The standard deviation of this bell curve is split from the mean to one standard deviation away, right? One standard deviation. One. Come on. I can't be that early. Negative 1s, positive 1s, meaning one standard deviation below and above the mean, right? Then this is 2 standard deviations away in both directions. Brody, you can join that team if you like. And this is 3 standard deviations away. Agreed? Are we good on this so far? Positive. Okay. So knowing that, we know that 99.7% falls between 2.6 years and 12.8 years old, right? So that would be 2.6 and 12.8. This is 99.7% of your data. How many segments of standard deviations are in between those two? 1, 2, 3, 4, 5, 6, right? What's the distance from 2.6 to 12.8? Would I add or subtract? To find the distance between the two numbers? I would subtract. So I'm going to subtract 12.8 minus 2.6 and divide it by 6 segments. And that would be 10.2, is that right? Divided by 6, and we should get 1.7. Could we also do it this way? What was the mean? 7.7. So we could even do this. We could take our 7.7, subtract it from 12.8, and divide it by 3. And you should still get the same value. Yeah. 4 feet 10 inches is equal to 58 inches. And 5'2" is same as 62 inches. Okay? So these are one standard deviation away. This is plus 1s, minus 1s. We want to know what percent of the class must be between those two, meaning I'm asking you, what's the percentage here? Didn't even need to do that much math, right?
Yeah, because we're doing this
Good.
or Monday or Wednesday.
Because we knew this part is true, it was easy to figure out one standard deviation above, one standard deviation below, 68%. Yeah.
Wait, so that percentage is going to be the same, right?
As long as the distribution is normal. Okay? Now, what if I ask for like down to 56 inches? But I wanted just what percent of the students fall between 56 inches and 62 inches? What would you say?
Plus 13, right?
Is it 13 or 13.5?
13.5.
So that 13.5 needs to be added to what number?
Say 60, this would be 81.
There you go. So 13.5 plus 68 is 81.5%. Does that make sense? If I ask you, what's the chance that a 6th grader is between 56 to 62 inches in height? It's 81.5%. That's also the probability. Okay? The percentage can also translate to probability, and that's part of today's learning target. Okay? All right, so let's go on to number 4. Number 4. Miss Bian hates these typos. So TVs from a particular manufacturer are found to last on average for 3 years without any need for service. The standard deviation is 6 months. At least what percent of the TVs need service in less than 2 years? All right, so we really have to understand the normal distribution curve for this one. Let's pull out some information. What's the mean? 3 years, right? What is the standard deviation? Hello. Yeah, I think they had OC first. I emailed them, but I didn't get anything back. Okay, thank you. Okay, bye. All right. So at least what percent of the TVs need service in less than 2 years? Standard deviation is 6 months. Since we have years, and 6 months is an easy number that we can easily manipulate. How about 0.5 years?
Yeah, 0.5 years.
Right? That will be 6 months.
Okay.
Does that make sense? So we can go either way, but I think it just makes more sense to go with 0.5 years since there's not going to be anything between 6 months and 1 year marks right now in this problem. Does that make sense? If they ask for if the standard deviation was 3 months, I would definitely say change everything to months. But because it was such an easy conversion from years and months to 0.5 for 6 months and keeping years as is, we're just going to go with years. Does that make sense? Okay, so standard deviation, give or take half a year. So, meaning, here's my mean at 3 years. So there may be some TVs that are in need of service half a year beyond that mean, right? Which would keep us at 3.5 years. And that would be 1 standard deviation above the mean. And 1 below would be 2.5 years, which is 2 years and 6 months, right? That's 1 standard deviation below the mean. What's up?
So now it included, right? Because it's less than 2 years or more than 2 years?
This is more than 2 years. We're looking for numbers that the TVs that need service in less than 2 years.
So we would start what we're finding it for after 2.5?
No. Well, you mean after as in to the left of it?
Yeah.
Yes. What I'm thinking was I was saying no because it's before 2.5 years. Does that make sense? 2 years is before 2 years and 6 months.
So it'd be 2%, right?
So I'm going to go 1 more standard deviation before or after. So 2 standard deviation away from the mean will make it 2 years. Yes?
So that's 2.5%. And also,
so that means I'm looking for what percent of TV fall under this part of the normal distribution, which would be 2.5%.
So on the test, can we answer it in -2 standard deviation?
If it's as easy as this, that's fine. But it's not as easy as this all the time, which is the Z-score that's coming up.
All right, bet.
Okay? Are we good? Anybody have questions about how we got 2.5%? No? So they're saying that there should be very little TVs that actually require service before 2 years. Only 2.5% of what they manufacture needs servicing before 2 years. In the same way, if it's a normal distribution, there will be very few TVs that would need more than 4 years before they need a service. Does that make sense?
Yep.
Okay. All right. Number 5. Not all values are exactly 1 or 2 or 3 standard deviation from the mean. or easy to figure out in your head. In order to determine the percentages and probability for these problems, we must convert the value to a z-score. Now, when I was taking this in high school, I didn't understand the difference between standard deviation and z-score, and I'm about to tell you my aha moment right now, okay? Yes. So, remember how everything's broken up? Come on. Everything's broken up into mean, and then one standard deviation away, one standard deviation away, two standard deviation away, two. Those are my z-scores, people. Whatever number of standard deviation it's away are my z-scores. So this is 1 for z-score, 2, 3, and so forth. Can there be like 0.5 for a z-score?
Yeah.
Yes. That's what that part I was reading is saying. It's not always going to be a full size whole number 1 for z-score. It can have all the decimals in between these values, okay? So just stay with me for now. And then right here. Okay. These formulas are easy for you to use to figure out exactly what the z-score would be. Okay? So if you know most of the information from these formulas, you can figure out anything else that you're missing. Okay? So if z is plus or minus 1, plus or minus 2, plus or minus 3 standard deviations, you can use the empirical rule to determine the probabilities and percentages. If not, you have to use a table, this table, not the table you're using to write on, this table, okay, to figure out the probabilities and percentages, okay? If not, you may have to use the formula can also be used to find the standard deviation or mean by solving for the unknown. All of those examples will be coming up right now. Success, a score of 89 is exactly 2.5 standard deviations above the mean. What's the z-score? 2.5. 2.5. So I'm going to label that here. Z equals 2.5. And X is any kind of random score that lands us on that z-score. Okay? Above the mean. So I'm going to do a little mini sketch of my hill, my bell curve. Here's my mean. I don't know what it is. The mean is unknown. But I know that if it's 1, 2, 3 standard deviations away, it's going to be between those two. That's going to give me 2.5 deviation above the mean at 89 points for the score. Is that making sense?
Yeah.
Yeah? Okay. Using that, and we know that the standard deviation is 10. If we know that the standard deviation is 10, each of these segments is going to be 10 points. 10 points more, 10 points more, and then you would get your score. So we don't know what this mean is. So we could work our way backwards, which would be how much less than 89? 25, right? Watch this. Let's use the formula. 2.5 equals 2. I'm going to go from 89, which is the score that I would have with 2.5 standard deviation, minus our mean, which is the unknown. That's supposed to be divided by 2. No. What's the standard deviation? 10. Okay. So multiply both sides by 10. You get 25. Hey, didn't we just talk about 25 just a second ago? How do we use that term 25 in this context?
We subtract it from 89.
Yeah, because it's 2.5 standard deviations away. 2.5 of 10 is going to be 25.
Yeah.
So there it is. So it's 25 equals to 89 minus the mean. How do I solve for mean?
Multiply.
No. Subtract 89 on both sides.
Oh, no, you're right.
You get a negative 64, and then you would divide both sides or multiply both sides by -1. So the Mean is going to be 64. Yeah.
On the test, do we have to show that extra step? Minus, like -1 and stuff? Or can we just write down the answer?
I'm okay with you setting this up and then giving me this. Okay? Any questions? Yeah. Louder? How did I get the standard deviation? It told me so. Right here. Right? So, wait time at a new burger joint is normally distributed with a mean of 9 minutes. So, let's mark our mean on the curve. Okay.
Is this what the test is gonna look like?
It's very similar, yeah.
Are we getting a study guide too?
No study guide, just a practice worksheet that is going to reflect very closely to what you're expected to know for the test. So here's 9 minutes, okay? Foldables will be a form of assistance.
No, will the test be in a folder?
No. Okay.
You know what?
6 minutes is to the right or to the left of 9?
To the left.
Left. That means Ariel waited less than the average time. Does that make sense? Yes? Okay. So if Ariel's waited only 6 minutes and her z-score is -2 standard deviation, we need to find the standard deviation. Okay? Let's think for a minute. How many segments of standard deviation do we have between 6 to 9 minutes? 2, right? Because it's 2 standard deviations away. So if they're equally divided for each of the standard deviation, since the distance between 6 to 9 is 3, and we divide that into 2 parts, each standard deviation is going to be a minute and a half. Yeah? Does that make sense? Okay. I'm going to use the formula now to show you how that works. We just made sense of it. We're going to go back and show you how this works. What's up?
I'm gonna ask you the formula on the test.
Yeah. So here's the x. X is going to be whatever piece of the data that we have. Okay? 6 minutes is not something that is that important other than that is the one that we're investigating. Okay? So 6 minutes, we're going to take away the mean. What was the mean? 9 minutes. And we're going to divide by what?
It worked.
Yes, it did.
Oh my god.
The standard deviation, which we don't know yet. We're not supposed to know. We figured it out by using logic just now, right? But I'm using what we know in order for us to use the formula and you can make sense of it, okay? Remember what I told you about these numbers? What are these numbers? Those are called z-scores. So since it's -2 for the z-score, I'm going to replace that z with -2. So the rest stays the same. 6 minus 9 divided by s. Then how do we solve for s?
What's 9?
So -2s, we multiply both sides by s. 6 minus 9 is -3. -3 needs to be divided by -2, right? And s is going to be, okay? So let's go back. Each standard deviation is going to be 1.5 minutes. So if I really wanted to be clear on that, I will put the word minutes next to it. 68% of the patrons weighed within what range time then? It will be 1 z-score away above and below the mean. So that would be what? 1.5 minute away. From 9 below is 7.5 to 10.5 minutes. What do you think? So most of the patrons at this burger joint is going to be waiting anywhere between 7.5 to 10.5 minutes.
First time I don't get a challenge.
Yeah? All right, number 7. The data below represents the cost of a small cone at 10 ice cream stores. If the standard deviation is $1.16, how many prices have a z-score less than 1.2? Okay, so let's pull out some important information here. We have 10 ice cream store prices for a small cone. Okay, the standard deviation is $1.16. Okay, and the z-score is less than 1.2. This less than part is going to be important later. Okay. All right, so let me write it out. Do I have my z-score? 1.2, right? Do we have a standard deviation? $1.16? Yeah. Do we have a mean? No, but we have data, so we can figure out the mean. Do we have the x value yet? A part in the data that tells me where 1.2 z-score is. We don't know that yet. That's what we need to find out. So first, we need to figure out the mean, so we can use our equation. Okay, so add them all up. 26. And then we divide it by how many numbers we have, which is 10, right? There's 10 values here, 10 stores visited, 10 prices. So we're going to divide by 10. Then we get 2.6. That's my mean. So I have my mean, 2.6, right? Let's put it together. Z-score is 1.2 equals 2. X is unknown. That's what we're trying to solve for. Standard deviation is 1.16, and I should subtract the x by the 2.6 we found by adding all the values of the store's prices for a small cone and dividing it by 10. Okay? What do I do first?
Divide or multiply.
Multiply both sides by 1.16. What do you get? What do you get? I don't have a calculator. I need your help. So I need you to multiply that and tell me what that is. 3.139. Like that? Okay, thank you. $1.39. Yeah? Okay, now what do I do? Add the mean to both sides. Oops. 2.6. We gotta line up the decimals, right? Oh yeah, this has a 2 at the end, doesn't it? Yeah? So that 2, can I drop it? We're talking about money, so can I drop it? If I were to round it and that 2 was a full 5, then we will round it up to a 4. Okay? But it's at $3.99. So at z-score of 1.2, the ice cream cone would be $3.99 for a small cone. Okay? So which stores, it says how many prices or which stores have a z-score less than $3.99? How many? Anything above would be these two. And then everything else would be below. So how many prices? 8 stores have prices, or 8 prices have less than $3.99. Okay? Are we good? Hope that made sense. Okay. Are you on 9? Cool. Data was collected on speed of cars traveling near schools. The mean speed was 33 miles per hour with the standard deviation of 8 miles per hour. Mean is 33. Standard deviation was 8. Mean is 33. Okay? And each standard deviation is going to be 8 miles per hour. Okay. Out of 200 cars that drove by the school, how many were traveling at most 45 miles per hour? Is that to the right of 33 or to the left? To the right. Okay. 45 is somewhere. I have no idea where. In terms of the z-score, I have no idea, right? But I do know that if I go up from 33, it'd be up 8 from 33, it would be 1 standard deviation away, right? What's 33 plus 8? 41. I'll do that one in blue. This is 1 standard deviation at 41. Anyone have questions about how I got 41? No? We're okay? All right. And another 8 would make it 2 standard deviations away from the mean. So that would be at 49. So this is plus 2 standard deviations, which is at 49 miles per hour. So it's between those two. So it's definitely not going to be a whole number z-score, right? So we need to figure out, we don't know what the z-score is, but we do know that x is 45 minus 33 for the mean and divided by 8 for the standard deviation. What's 45 minus 33? 12 divided by 8. So z-score is 1.5, okay? You don't have to figure out the percentage. It's on the table as decimals. So the way you look at the table is this. I'm going to go ahead and pull up our z table on my screen. Okay. The left side are the first 2 digits of whatever z-score you have. One before the decimal and one place after the decimal. So if it's 1.5, I'm looking at 1.5 here and going to 0 for the second place after the decimal, right? Because there's no other values after 5. Does that make sense? So where does that intersect? Right here. Do you see it? That's your percentage to the left of that z-score, okay? To the left of that z-score. So let me go back. Where are you? Did I skip it? I should have bookmarked that spot. I can't find number 9 again. Nope. Application, there it is. Wait, how come it's all blank? There it is. Is that it? Nope. What is wrong with me? I thought I bookmarked it. No. Oh, that is 9, but where's my other 9? Oh my gosh. Seriously. Seriously, Miss Bian, I had only 10 minutes, and this is how I wasted. There it is. Found it. Sorry, guys. I had it bookmarked. Okay, so 1.5 right here. The purple line right there is 1.5 z-score, right? So the area to the left of it, all of this, if I were to write a percentage for it, it would be as a decimal. Percentage as a decimal would be 0.5. 9332. Okay. But, oh, that's exactly it. So if it's at most 45 miles per hour, it's everybody in that shaded area, right? So that would be 93.32% of the cars were traveling at most 45 miles per hour. You good? Okay, one more. We got this. Go to number 10 for me, please. Which is this one, Minecraft. I hate that they keep having spelling and grammatical errors. The number of hours that Jake plays Minecraft per week is normally distributed with a mean of 24 hours with a standard deviation of 2.5 hours. What is the probability that next week he will play Minecraft over 1,620 minutes? What is it, Julian?
27 hours.
How'd you get that so quickly?
I looked at it beforehand.
Ah, I see. So remember, how many minutes to an hour? 60. So remember I told you you want to knock out the minutes so you can get just the hours at the end. So should I multiply by 60 or divide by 60? Divide, because I need the minutes to be below in the denominator to knock them out, right? Then we have 1 hour at the top. So divide and we get 27 hours like Julian said. Are you okay? I moved through that pretty quickly. So my x is going to be 27. My mean is going to be 24. And standard deviation is 2.5 hours. Okay. The probability is the same thing as the percentage that's covered under the curve. Okay? So we're looking for the z-score to figure out the percentage of it. So how do I find the z-score? Z equals. What should be in the numerator? I'd like 1 minute, guys. What should be in the numerator?
27.
Yay, 27 minus 24 divided by 2.5, which is 3 over 2.5, which is
1.2.
1.2. Look for 1.2 on your normal distribution cumulative table. 1.2, 0.8849. In my curve. Oh my gosh, that's a terrible curve. That's still about a curve, but 1.2, here's the mean. That's the z-score we're looking at, 1.2, right? To the left of it is going to be 0.8849. So how do we figure out if we are going over the 27 minutes? I want this side. Subtract from 1, right? If I subtract that from 1 with your calculator, you should get a total of 0.1151. So what's the probability he'll be playing more than 27 hours?
11.51%.
You got it. What do you think? Lisa does not seem to have a lot of luck with goldfish. The length of time before flushing is normally distributed with a mean of 42 days. X bar equals 42 days. And a standard deviation of 8 days. Okay? If she buys a new goldfish on January 1st, what is the probability that it will live longer than Valentine's Day? Okay, January 1st. Do you know how many days are in a month of January? 31. And then from February 1st to February 14th, how many days is that? 31 plus 14, 45? 45 days? Okay, so we have our X value of 45 days. Okay, then we can find our Z-score. by using my 45 minus 42 divided by, what's my standard deviation here? 8. Okay. Then we have 3 divided by 8. What's 3 divided by 8? .375, yes? Okay, table, that's my z-score. Look for 3, and then do I look for 7 or 8? Because it only goes to 2 digits, so do I look at 3.7 or 3.8? You round using your conventional rounding rules. So this is similar to 0.38, agreed? Yes? Okay, look for that here on your table. Okay, I'm gonna highlight in green, 0.3. I'm gonna keep going until we get to 8. Yeah? Is that good? 0.6480. 6480. So my probability from the table, that's not it. 0. Is it 60? 6480, right? Now, we want to know if it will live longer than 45 days. So do we look to the right or left? To the right. So if this curve tells me it's going to be here at 0.6480, right? I need this side. So what do I need to do with this number again? Subtract from 1, and we should get 0.352. So that's 35.2% chance that it will live longer than 45 days. Okay? Yay, we got through it. You were my